that we do and our experience in the industry is often the preserve of companies who can afford the cost and the risk of tendering. These are the big primes. So AI, as I hope we'll learn today, promises to change that. We're going to hear from two people on stage, and or three actually, and I'll read their bios. So Abu Odiji is the CEO and co-founder of TenderTrace. You'll hear from Abu just after I finish here. Abu has spent over 15 years assisting government agencies in the UK and PNG and in Australia with their tech and their cyber goals. He's an advocate for open government, diverse, inclusive procurement, and he established TenderTrace, which is a data intelligence software as a service platform designed to empower government suppliers with insights, crafting go-to-market strategies, navigating the competitive landscape, and substantially growing their public sector revenue. So TenderTrace's services are to major international vendors, to local Australian SMEs, and their commitment extends to collaborating with government agencies to bridge the SME inclusivity gap, which is what I've just been talking about. And Sean, the founder and chief executive of AutogenAI. AutogenAI, for those who haven't done their homework before coming, is bringing the latest advances in AI and natural language processing to the task of producing winning tenders and proposals. So Sean, prior to his role in Autogen, has had a fairly wide and varied career. He's designed and managed large-scale public service contracts. He's managed businesses turning over in excess of £75 million. And he was also the founder of Corndall, which grew to employ 350 people before its sale to THI Holdings. So Sean has experience in the space, and we'll be hearing from him a little later too. And on the panel later today, we will have Rob Sutton from Mirigan, who I've known for quite some time. Rob works in the drones, robotics, and AI consulting space in defense, and he's worked in a range of defense industries, big and small. He understands tendering from a range of different perspectives. So we'll get Rob's perspective on the panel a little bit later. So the day is split into a few components. First, we'll hear from Abu. We'll hear about the budgetary landscape for the next financial year, now that we've had some clarity from defence, and some of the opportunities available to industry as part of that. After Abu, we'll have a brief break, and then we'll hear from Sean, who will take Abu's presentation and talk a little bit beyond it to how AI can help as industry seize those opportunities. And then as mains are served, we'll have a half-hour Q&A with myself, with Rob, Sean, and Abu on stage. And so I encourage you all to start jotting questions down now. When it comes time to the Q&A, there will be an opportunity for audience questions. So if you'd like a question asked, I'll have to ask you to either stand up and raise your hand, or otherwise let yourself be known to me so I can pick you out from the audience. And then make sure you yell your question loud enough for us to hear it, but not so loud that you get recorded on the podcast. So Abu, I will invite you up on stage to talk us through.
Thank you. There is a lot of data, so I might be looking here sometimes. Hi, everyone. Good morning. And we do have some technical issues. So bear with me. Almost there. I hope everyone is having a good day today. Happy Friday. Do we have questions? Someone from the cameras?
Here we go, you're coming up.
What's your best joke?
Oh, what's my best joke? Oh, sound like my kid. Dad, tell us a joke. Okay, by way of introduction, my name is Abu. I know they've already, you guys, thanks, Erin, for that intro. The focus today will be around government, and can you see the screen, or is it just me?
Bottom left hand on the wall behind you. Bottom left hand one. Told us that's bigger.
No.
And we can close the curtains.
Brilliant. And Grant, can you help me find my mouse, please?
Which screen was the next one?
Not yet. So, by way of introduction, what we're going to talk about today. So, I will be presenting data around FY25 opportunities in defense. So essentially, how we'll track that today will be, thank you very much, will be across looking at, the fiscal year as of date. We'll bleed through the budget. I mean, we've talked about the budget strategy. That's just talked about in the last 10 days. So we'll bleed through that, and then we'll focus on some categories and some industries over the next fiscal year. Now, talking about and I like to preface this, the data you're seeing right now, and you will see across my presentation today, was generated all on Tender Trace, right? So we're an AI platform that would aggregate all that information and spit that out to you in actionable intelligence, right? Ian did a great intro, so thank you, Ian, on that. But it's all about faster time to data for us. And that means the data is readily available. It's in your hands, ready to go. And it takes about, some of our customers are here, so they might challenge this, 20, 30 seconds to really get into the crux of analyzing, 30, 40, $50 billion worth of government spend, okay? So looking at the current fiscal year, before we shoot into next year, what we can see is that there's $38.6 billion in defense spend so far. Now, bear in mind that this was aggregated about a few days ago before I headed out to Canberra. Now, this is across 449 categories, 18,000 contracts, and that's been with 4,700 odd vendors. I think this is very important information as to the value of defense in our marketplace and the enormous opportunities that's there for us. So compared with the rest of government spend, we're looking at, which is $22.5 billion, right? We're looking at defense growing year on year at 22%, whilst year on year, rest of Fed is declining at 50%. Now, you'd ask me, well, this deal's sitting. I think it's important to measure it. The reason why we measure this data is, where do you operationalize? Where do you build yourself up for success? So we know that around 54% of that amount itself was awarded in Q1. When we go to the end of this, the second half of this presentation, you would see where we'd analyze where those deals tend to land with regards to expiry contracts, so you guys can operationalize correctly. I lost it. There you go. Now, one question our customers tend to ask us is, well, do we have access to these opportunities at all? Right? So what we measure as well is deals done within panel arrangements and what the procurement methods are. So out of that 38.6 billion, 34.4 billion was done outside the panel arrangement, and within that, 25.6 billion were invite-only tenders. Quick insight on the category. Most spend have been sat with military fixed wings category at 21% of that value. So let's look at some notable vendor activities. This will be the only time today I will talk about a vendor or some vendors. So let's have a sense of what's happening. So largest single contract, Hanwha Defense, 4.6 billion. A lot of construction companies and infrastructure companies work with defense. Fulton Hogan sees themselves at 363% year-on-year growth, the highest of any infrastructure company with defense right now. The most number of contracts for this fiscal year so far is with Thales, and that is across 449. And we're seeing a 55% decline year-on-year with management consulting firms. I think this is important to note that the data, the end of the year, we're not nearly yet there, but what we can see based on the patterns is that for fiscal year and looking back is that for fiscal year 23-24. Big start to the year and a nice clean line right to the end of the year. Would that curve up a bit? Maybe, we don't know. But when you compare that to the rest of government, we see again big start to the start of the year, and then it flattens out and then drops right down. But it does represent a dynamic movement and engagement within the marketplace in defense, just so you know. I did promise I wasn't going to talk through this, but we all know what the huge record-breaking amount that Albanese's government has promised. So 330 billion, right, to rebuild the integrated investment program and support defense posture and structure. And that's going to be spread across the next 10 years. Future opportunities. So here's the sort of meat of what we're going to get into today. So we're looking at FY 24-25, which is starting July. And the reason why we tend to look at operational spend and contextualize that with budget spend is because operational spend is critical in how you do manage your run rate business, or really engage the market, or analyze or understand the market, or see where the money's moving. So from a compete perspective, we know that when you analyze operational spend data, you understand how you pit against your competitors or your competitive landscape. So in next fiscal year, $45.2 billion across 302 procurement categories coming up for expiry. Now, we know this is across over 5,000 contracts and with 1,700 odd vendors. When we look back to the growth of expiry contracts year on year, compared to the previous year, we're seeing a 19% growth. So there's 19% more expiry contracts this year compared to last year. We built categories there, software taking 10% of that value and infrastructure 40% of that value. The current size of defense actives contract. I think this is good information, guys. I think what we measure in tender trace is what's the active holding for a government department. So how much do they have right now with vendors? And right now with vendors, that is $217 billion. Now, the current size of next year's expiry is $33.2 billion. Notable expiry contracts. I'll focus on maybe, the estate and maintenance on operations service contract at $5.4 billion, and maybe the professional engineering services, which sits in that same category at $335 million. Some of these contracts will be familiar with some of you people in the room. Now, let's look at infrastructure and maintenance, and within that, the category of building, construction, and support and maintenance and repair services category. So the size of that is 17.1 across $257 billion. $10.8 billion was originally awarded in an open tender process. That'll give you a sense of what you would need to do with regards to engagement should these contracts come up for renewal. 55 of that is sitting at the bottom end of the fiscal year. So essentially, we also measure where this will sit, and and that is Q4 for the year. And the trend in the category is what we're seeing is there is a 11% year-on-year decline compared to the last 12 months. What does this mean? So we go, well, here is 17.1 billion. Look back 12 months and measure that and see if there is a decline or an upward trend, and there is a decline at 11.7% within that category with defense. Okay, now there's a lot of noise here, but I'll focus your attention on a few things. The contract titles, the values, these are the top 5 contracts within that category. But the amendments, the reason why TenderTrace analyze amendments is for a couple of reasons. Firstly, it helps our suppliers understand the land and expand strategies for their competitors, right? So you're going in at 1 million and then growing that contract up until it's, the hundreds of millions. So we analyze that, we measure that with regards to the market average and the timeline average as well. So you can see there that there are 41 amendments there. For that second contract, it's 81 amendments. So that will tell you that those contracts might not possibly come out to market. There might be a renewal or an automatic amendment to those contracts. What we've seen with the transparency score is an interesting one. So we help government measure how good they've done across their contracts. So when you see the transparency score, what does that mean? It means that our AI engine is saying they've not really done their job really well. So we've scored them at 68%. This is using the UNSPSC standard to score government contracts. Vendor activity with buyer in the last 12 months. So the vendors to these contracts, you can have a sense of what their trajectory is, how their growth is over the last 12 months. The top vendor is growing at 749%. In the last 12 months, they've done $502 million with defense. Engineering services, professional engineering services category. So far, $1.4 billion have been spent within that category across 1.4 billion expiry contracts. Procurement method, open tender, 1 billion. Number of contracts sits in the Q1, 35% weighted there, and year-on-year decline at 37.2%. A contract I can focus on would be the integrated work package at 72 million. Actually, no, the 136 amendments across the major service provider integrated works program. Some of you know that contract itself. The particular vendor to that contract is growing at 324% within defense. IT, information technology, broadcasting, and telecommunications category. It's a bit worthy, isn't it? The value is 1.72 billion across 900 odd contracts. Procurement method is limited at 1.3 billion. So you can see how defense really engages the market from a technology perspective. We invite who we know or who we trust. It's all weighted to Q4, and there is a 53.4% decline there. I will focus on where we have no activity or growth. It means the vendor of the enterprise information management systems integrator, the third one down, right, has not done any engagement with defense over the last 2 years, really. So that's how we measure that. By the way, I see people taking pictures. We'll be giving a report to everyone who attends at the end of the session. Temporary personnel services category. This is a bit light, and I'll blitz through it. 32 million for temporary personnel. I mean, we've really cut down on that. And a 50% decline. And yeah, I can see senior physiotherapist there. I'm not sure what that's all about, but yeah. Management consultancy. I believe there'll be a few management consultancy people in the room today. So let's have a sense of what's happening there. Now, we're not measuring categories now. What we do on TenderTrace is we can measure industry. So what we're saying is, let's aggregate all management consultancy firms, which is done by AI, and let's analyze them and what's happening in the marketplace. So the same sentiment, so the same approach. 117 contracts expiring with management consulting firms. Most of those contracts were through limited tendering process, weighted in Q2, and a 54% decline spend with management consulting firms. I think you guys can contextualize this with your knowledge of the field. Here are the top 5 management consultancy firms contracts. You might see one that looks very similar with regards to, their engagement. So 35% year-on-year change, 58% decline year-on-year change. So that might be the same vendor. I bet you can guess who. And finally, defense contractors, so primes. So we put together a few primes. So 3.9 billion in expiry contracts. That's across 520 contracts. 2.1 billion across limited tender process. You can guess why. 40% is weighted in Q1, and it's a 6.1% decline. It's the lowest decline across all industries. So primes are actually doing well in defense. I'll give you a sense of that. But those contracts, you can see that there are actually a decline across those vendors who hold the top contracts. It could be that the length or the terms of the contracts they have with defense. So actually, in summary, as you can see, there's enormous opportunities with defense. The question is how do you navigate the noise? I think that's where AI comes into play, to help build a robust understanding of the marketplace, be laser focused, and really just the ability to hone in on what's meaningful for you. I really appreciate your time today. Thank you.
So it was interesting to see how big all the declines were across all your slides until you got to the primes. And then the decline's a lot smaller. So we're going to have a short break, and then we'll hear from Sean about how AutogenAI can help change the defense landscape and open some of these opportunities up to companies other than the primes. Thanks. So if you can't hear me at the back, just give me a note. I'm going to introduce Sean to give his speech now on how AutogenAI can help companies access some of the opportunities that Abu just talked us through before. So Sean, please come on up, and if you could all join me in welcoming Sean up to the stage. Thanks.
Thank you, and I'm not mic'd up, so I need to have a loud voice.
Just getting you mic'd up, mate.
Great. I've got my... Right, excellent. Turn it off. Right, excellent. Can you hear me? Yep. We're good? I'm mic'd up. Hopefully we can move through the slides. We've got the pointer in the right direction. There we go. We're good to go. Can I go back a slide?
Yes, right click on that.
Right click. Okay. Okay, you seem to be in the middle of my presentation.
Sorry about that.
That's no worries. Where's the laptop?
I just adjust this as well. I've got pumped.
All right. Let me start. If you'll forgive me, I might just take 5 minutes just to introduce myself, say a little bit about my journey and how AutogenAI came to be. Then I'm going to talk about why I think large language models are going to change the world. And I'm not going to spend much technological time talking about that. I'm going to try and give you a historical perspective on why I think that's the case. Then I'm going to talk a little bit about this new emergent property that artificial intelligence has of being able to read and write. And then I might talk a little bit about sort of adoption metrics. I've been told I can carry on over lunch, so please do start eating when the food is served, because I'm very happy just to carry on talking and taking questions. So please don't let me talking get in the way of having a good lunch, which is the primary purpose, of course, of being here. So I have had 3 careers. In my first career, I was a bid tender and proposal writer. So I actually started off as a researcher. Of course, becomes so ubiquitous that it's no longer a competitive advantage. It's just a must. It's just a must-have. So on the back of being a very good researcher, because I was using Google, I got promoted quite quickly and became then a bid writer. So I was writing proposals primarily to government, but also sometimes business to business to deliver the sort of services that Abu was talking about kind of earlier that government buys and buys through competitive tendering. Then I became a bid manager and a bid director and sort of worked my way up the corporate world. But I'd started from and always had one foot in winning work through writing words. In my second career, I started a management and technology training business called Corndell. And I started that in September 2016. And I grew it as the founder and chief executive from 0 people in September 2016 to 250 people in September 2020, 25 million pounds turnover, 5 million EBITDA, and I sold it. I sold it in September 2020 to a German private equity company, and I sold it for 50 million pounds. I then fell out with the private equity company, and I left that business in September 2021, and I retired. I retired for 3 weeks. It was very boring 3 weeks. I'm not really cut out. It is really interesting going from being a founder and working and having work on your mind literally 24/7 to going and sitting on a sofa and watching YouTube videos. I found it slightly discombobulating, might be the best sort of word. But I was extremely lucky And I think most of such a lot of success is being in the right place at the right time. And in September 2021, in my 3 weeks of retirement, my best friend Andy phoned me up, and he works for Google's DeepMind. He works on the protein folding team. So he's one of the researchers on the AlphaFold paper, having solved one of the biggest biological mysteries of the last 100 years, how proteins fold in on themselves. He's, as I say, he's researcher number 12, so he won't win the Nobel Prize, but the top 4 or 5 researchers definitely will for their work on this. And he said, hey, Sean, I know you're bored. You should look at this new technology called large language models. And when Andy tells you to look at something, you look at something, because he's super smart and he knows, kind of really the cutting edge kind of tech. He said, you should look at them, Sean, because you'll find them interesting, because they can do what you said computers would never be able to do. They can read and write. And I said, don't be silly, Andy. Of course, I spent 20 years writing as a career. Let me assure you that computers are not able to read and write. And you're a mathematician. You don't understand reading and writing, right? I'll tell you about reading and writing. But as I say, I was bored. So I took a look at a number of different large language models, and I was blown away. Computers can read and write. That is going to change the world. And I'll talk a little bit about why it's going to change the world. That is the most profound breakthrough, at least since the internet, and probably a much more profound breakthrough actually than the internet. So I had time on my hands. So I was just playing with these models, and I deliberately used the word playing. Playing was what I was doing. So I translated Paradise Lost into modern English. I used what is now a really common technique, but at the time, we were all just inventing this stuff together at the time, a very small group of people, multi-prompt learning, to write new P.G. Wodehouse one-liners. And I was sort of just loads of fun playing with the technology. But as I was playing with it, I kept thinking back to my first career, writing bids, tenders, and proposals, the business of winning work through writing winning prose. The best, only the best. The reason I really love kind of tendering and proposal writing is because there is a really clear criterion for success, right? You win or you lose. Like if 10 people are competing for a contract, 10 of them are going to write a good bid. 5 of them are going to write a great bid. You have to write the best bid, right, in order to win. So there's really clear criteria for winning and losing, for success and failure. So I raised some money. I put a small team of people together around me. Half my early team were bid, tender, and proposal writers. And half my early team were machine learning engineers and data scientists. So we brought a deep understanding of the problem that we were trying to solve and combined it with a deep understanding of this new emerging technology. So we built then out till September 2021, and we launched the first version of our software. September 2022, when we launched the first version of our software. And we started showing companies that write bid, tenders, and proposals. And I don't know what people thought. Their jaws would hit the floor. I think they thought that maybe I'd kidnapped like 150 writers and had them in my basement and was just working them really hard. And you sort of, I've never really understood the being too soon kind of before, but I was starting to understand it. I was like, I mean, this is a magic machine I'm giving people, and people going, it's a magic machine. It's terrifying, right? And then 6 weeks later, a small piece of software, which some people in the room might have heard of, called ChatGPT, came out. And suddenly people understood what we were doing, right? And suddenly generative artificial intelligence and large language models suddenly developed this audience. And then again, that was then a catalyst for enterprise level specialist software like ours, which was able to demonstrate real business benefit immediately. That suddenly then was a catalyst for our growth. So in our first year, we got 150 customers. We won over $1 billion worth of work for customers using our software. We raised £65 million from some of the world's top venture capitalists to build out the best engineering team in the world. We drop new functionality every 2 weeks into our software using that team. And we're continuing to grow at pace here in Australia, in the UK, where my engineering team are all based, with myself, in the US. And indeed, we've got customers now on 4 continents using us. So that's a little bit about AutogenAI. I'm not going to do a huge sales pitch for AutogenAI. Instead, I'd like to talk about why large language models, companies like AutogenAI and hundreds of others, why this technology, a bit like electricity or a bit like the internet, is just going to be in everything in 10 years' time. And that is a sociological thesis, not a technological thesis. The technologies that change the world, I'm going to try and persuade you, need to do two things. The first thing is the thing that they do needs to be fundamentally human. So there's no point a technology doing something that humans don't do, right? It's just a waste of time, right? Tools are tools for humans to do the activities that we do. And secondly, that the thing that the tool does needs to speed up that fundamentally human activity by orders of magnitude. So you don't just make it like 5%, 10% better. You make it like hundreds of percent better. So if we go to the abacus, 2700 BCE, what does the abacus allow you to do? Well, it allows you to add up and it allows you to multiply faster. So what? Well, if you can add up and multiply faster, it actually allows you to do more complex trade. So you can swap 7 sheep for 1 chicken and half a cow, right? It allows you to do that trade. By speeding up the maths, it allows you to do more complex stuff. And trade, swapping things with one another, is fundamentally human, right? And it's a fundamentally human activity, and it's something that the abacus speeds up by orders of magnitude. So the abacus changes the world. If you fast forward 4,000 years, you get the invention of the printing press. What does the printing press allow us to do? Well, it allows us to share ideas, to persuade others, to put our opinions down on paper and kind of give them to others. And turns out sharing ideas, communicating ideas is a fundamentally human activity, and the printing press speeds that up by orders of magnitude. Steam engine, and that, by the way, that directly leads then to the scientific revolution, right? Because you are now able to share scientific ideas, and science is a discipline more than anything else that has to build on the past in order to progress. Reformation, Renaissance, kind of all of these things kind of just enabled by the printing press and that fundamental increase in speed of sharing ideas. 18th century, the steam engine. So the steam engine, of course, literally speeds up locomotion, getting places, but more importantly, it speeds up manufacture and making things. We humans like making things. Making things is fundamentally human. Steam engine speeds that up by orders of magnitude. We're talking a little bit on our table. One of the things, of course, the steam engine speeds up is the manufacture of cloth, which prior to the invention of the steam engine was done by water power mainly. Why is cloth not made by steam engines anymore? Because electricity happens, right? And electricity is now the thing that's speeding up the powering of machinery, of tools, allowing us to make things even faster. Right. Have I lost my mouse? Right, we'll do it through here. Okay. We'll try this one. Excellent. So radioactivity, the internet. Internet in my lifetime, a technology that, or at least popularization of the internet, that speeds up the sharing of knowledge and ideas. And then we get to 2017. I'll talk in a moment about why 2017 is the right time to think about the invention of large language models. What do large language models allow you to do? They speed up the creation, right, of knowledge and ideas. In our case, text. So I'm going to talk about reading and writing because I think they are so fundamentally human. But large language models allow you to read orders of magnitude faster and write orders of magnitude faster. And reading and writing are about as fundamentally human activities as you can get. And this is a technology that speeds them up, not 1 time, not 2 times, hundreds of times, allowing you to read and write to a scale that wouldn't have been in any way possible prior to their invention. So if you're like me, kind of goes, so that's why I want to try and persuade. Now, all technologists will stand up and tell you that their technology is going to change the world, right? And there's a fairly obvious vested interest they have in doing that. I don't believe large language models are going to change the world because I work in it. I work in large language models because I think they're going to change the world. And that's why I think they're going to change the world, because reading and writing are fundamentally human. It speeds it up. But if you're like me and you spent 20 years writing for a living, when I first saw large language models, I have to say I was like completely awestruck by them, but I was also slightly scared, kind of perturbed. This has changed my view of humanity, kind of, computers couldn't, well, we're all used to computers being able to add up and multiply faster than us, right? To be able to pull out data and aggregate it and give us percentages, that's all fine. Computers being able to read and write, that's quite transformative. And so if you're like me, you go, well, how on earth did this happen? What happened? What changed? Well, three things changed to give us this emergent power of reading and writing. The first thing is that these massive neural networks, these massive brains got bigger. So in 2018, poor old Elmo, one of the first large language models, Elmo's only got 94 million parameters. If we fast forward something like GPT-3, GPT-3 has got 173,000 million parameters. That's a logarithmic scale in the y-axis. That's geometric exponential growth. So these brains are getting massively bigger and massively faster, bigger. So bigger brains helps, but it's not enough on its own. The next thing these brains have done is they've read more. And modern large language models haven't just read more, they've read everything. It's quite an important point, right? So there are 726 billion words of digitized. So if something, so rather than saying large language models have read everything, I should say they've read everything that's ever been digitized. So there might be some scrawling on the toilet cubicle, some graffiti that they haven't read. But anything which is kind of digitized has been read. So a vast majority. That is 726,000 million words. 726 billion words, right? If you or I were to try and read that entire corpus of human written work, if we read a word every second and never slept, it would take us 26,000 years. There's nothing more to read. There is no more training data to be had. They've read everything, right? Kind of these large language models. So massive brains, and they've read everything. But that's still not enough. Actually, the key insight that gives the key insight coupled with the size improvements and the scale of training data improvements is a paper which is released in 2017. People often say that Google are being left behind in the AI race. You might look at who invented kind of large language models on this. And this paper, Attention is All You Need, released in 2017, proposes a new way of building the brain, a new architecture for the brain, a new structure for the brain. And that is the transformer architecture. So if you hear of ChatGPT or GPT-3, or that GPT stands for generative, pre-trained, transformer. Generative, it makes stuff up. Pre-trained, it's read all of that massive corpus of text. And transformer, it's built on this transformer architecture. And the transformer architecture is a simple network architecture based solely on attention mechanisms. Well, what's an attention mechanism? Well, it turns out what large language models are trying to do is predict the next word to come after, or rather more accurately, the next syllable or next token to come after the tokens that have come before it. And in most models where you're trying to predict the next thing in a sequence, the most important thing in predicting the next thing in a sequence is the immediately preceding thing in that sequence. But it turns out in language doesn't work like that. In sentences, the most important words in the sentence and what the sentence refers to often can be right at the start of the sentence. So if I say, the King of England was riding his bicycle and went round and round the hill, then went to the top of it, then crashed into a tree and banged his head. His head is the King of England's head, right? It's the thing right back at the start of that sentence. Attention. So what you need to do is you need to get these massive neural brains to pay attention to the most important bits of the sentences. And the transformer mechanism essentially encodes that in mathematics, which gives you a way of them being able to do it using neural network architecture. So those three things, you have this new architecture, you make it massive, and you train it on everything that's ever been written. That gives this emergent property and this kind of incredible emergent property of computers being able to read and write. So what does that mean? Well, how smart are, like reading and writing, what does that mean? Well, reading and writing means that you can take tests, the sort of tests we give kids, the sort of tests we do at universities and give adults and other things. Well, it turns out that the biggest modern large language models are massively better than most humans at those sorts of tests. So the bar exam, again, very linguistically focused. GPT-4 scores better than 90% of lawyers taking that test. GPT-4 scores in the 86th to 100th percentile on maths, history, biology, and physics. Right, so just you know, it is in the top fifth of people taking that test of humans. It's better than 4/5 of humans. Advanced sommelier theory. You know, the GPT-4 has never tasted wine, but is still able to do better than the 3/4 of humans in the wine exams. Creative writing, not so good. And strangely enough, now again, coming from philosophical background, applying historiography to this, you know, one of the key things we do is, of course, evaluate sources. Why are people telling me this? Strangely enough, the computer programmers tell us if there's one thing which isn't going to be taken over, it's their jobs. So they put that. They say so. Hard computer programming tasks are still very tough for large language models. They require a sort of logical thinking, which isn't natural to their sort of linguistic constructions. Adoption, lots of people will have seen this now, but I think it's because it still has the power to astonish. Netflix, 3.5 years to get to 1 million users. 1 million users of Netflix, it took 3.5 years. Kickstarter, 2.5 years to get to 1 million users. Facebook, 10 months. 10 months from starting Facebook to get to 1 million users. Instagram, 2.5 months to get to 1 million users. You build a piece of software, you release it. 2.5 months later, you've got 1 million users. ChatGPT took 5 days. Showing again the incredible draw of this technology, the incredible surface level power of it for people looking at it. I was asked to talk a little bit about security and trust. Can large language models be secure and trusted? The answer is yes. You need to put a whole load of safeguards and guardrails around them. But with those safeguards and guardrails, it's as safe as any other technology. And again, can be deployed cloud-based or deployed on-prem, depending how customers want to do it. Every new technology goes through the same adoption cycle. Not everyone, but most of them. First phase, the technology is going to kill us. Second phase, it's going to steal all our jobs. Third phase, I don't know what all the hype was about. It's rubbish. And then fourth phase, people get to, okay, this is now a tool which we're going to use, and it's just part of the world. You laugh then when you're using the tool. Like when I say I used Google, it's like, well, of course you use Google, right? It no longer even feels like technology, right? It's just a part of the way the world is. And I said this before, but really, with the adoption of large language models, we are like in 1992 with the internet, right? That's where we are with it. We are right at the start of this journey. I can tell you they're going to change the world. I can't tell you how. Right? You know, I can't tell you Facebook and Amazon and Netflix and Google are going to be invented in 1992, but you can see that there's going to be this tide of change that is going to happen. And as with any technology, as with me as the researcher, when I had a good year advantage, but that was it. It's not that AI is going to take your job; it's that people that use AI are going to take your job. So, where's all this going? And now I am going to talk a little bit more myopically in the bid writing, tender writing, and proposal sense. I want you to imagine a world where software reads all of your background documents for you and tells you what you need to know in minutes. So the customers dropped 1,000 different documents, 10,000 pages long for each of those, and your bid team's going to spend 2 months synthesizing that information. Well, you don't need to do that because we've already built software which will do that for you in seconds. Imagine a world where software is your subject matter expert, relaying exactly what service requirements need to be delivered, where you don't have to be phoning up someone to say, hey, how do we do this? And they go, I'm busy delivering the service, get off my phone. Or they write you an answer and it's an answer to a completely different question than the one you asked. The computer will just automatically take all of your knowledge, find the relevant knowledge, and then repurpose it for the question at hand. Well, again, you don't need to imagine that because we've already built that. Our software already does that. Imagine a world where you don't have to go and find policy notes, previous ITTs, RFPs, and supplier background information because they are all retrieved instantly by a smart computer that understands what it is you're looking for and can go over your entire knowledge base and indeed entire public knowledge bases and bring that information back instantly. Well, again, you don't need to imagine that because we've already built it. That's already here. Imagine a world where you can research multiple geographies, service lines, and customer groups at the click of a button. You don't need to imagine that. We've already built it. It's already in our software. And then imagine software that makes you a cup of tea and gives you a biscuit while doing all of your work for you. You do need to keep imagining that. That's we're still things that us humans need to do. So that's it from me. Thank you all for listening, and I'm really looking forward to the Q&A in a moment.
Thanks, Sean. I've got a list of questions here. You've answered about all of them, so I don't even know if we need the Q&A. But ladies and gentlemen, we'll be back on stage in 5 minutes with Sean, with Rob, and with Abu. If you've got any questions, please, as I said, raise your hand and we'll put them to the panel. Thanks. Thanks.
Almost there.
Guys, the mic's alive. So
sorry.
oh, that's all right, just FYI. All right, ladies and gentlemen, we've come to the last part of the lunch. So we're going to be going through some Q&A. As I said, I've got some questions here, but they're not exhaustive. So if you have a question you'd like me to ask or, throw to the floor, just put your hand up or stand up or make yourself obvious. But Sean, we'll start with the question that I have for you, which I think you've just spent about 20 minutes answering in your presentation. But what I've asked is, why is AI more than just a flash in the pan? You've given us that, but can you talk about why AI is more than just a flash in the pan in defense specifically? This is a competitive environment with quite high quality standards. So how is all that going to translate into defense procurement?
So look, let me answer defense and then defense procurement. I did a really interesting panel in Washington with the US Air Force's generative AI Supremo and another contractor who was working with the CIA on large language models. And they, of course, like any general purpose technology, large language models are general purpose technology, like electricity, like they're going to have hundreds of uses, but computers can read and write. So think of that in the context of an intelligence agency that is getting millions of reports around the world. You've got news reports, you've got operatives, agent reports, you've got your own agents, you've got others, and you're getting all of these millions of kind of data points, and somebody has to read that information and synthesize it. And often you don't have one human reading it, both because of capacity and because of security, that you want to segment that, but you do want to be able to pull ideas to spot trends. So that would, I think, just be one example I would never have thought of for an application of large language models, but computers can read and write. So any activity that requires lots of reading and writing is going to be transformed, and that is a huge amount of human activities in work and indeed in leisure. If you look at the multimodal capabilities of artificial intelligence now, if you look at some of the latest models that OpenAI have brought out, and Google described their Gemini models as being natively multimodal. Now you've got spy satellite imagery, which can be read and understood in the same way that the text can be read and understood. And of course, that feels profoundly defense is definitely not my area of expertise, but that feels profoundly game-changing, as it will be across all sorts of areas of human endeavor. And of course, to use large language models and to use artificial intelligence in those contexts, you need to have the very highest levels of security that you can get. So I think that shows that large language models can be deployed in the most secure environments. And there's a number of different ways of deploying those models that we, for example, use at AutogenAI. So for example, once you've put data into a large language model, there's no state is stored. So as long as you're securely putting the information in there encrypted and securely getting it out encrypted, there's no problem with the model per se. It's as secure if you're using a cloud-based solution as any other cloud-based solution. And of course, then you have more secure options for completely isolated on-prem type solutions as well, where security is kind of the utmost. I think just the last thing I think is interesting is some of this becomes, particularly in tender writing, it becomes a question of how much you want to be able to share information, but there's some information you don't want to share. But similarly with the library, where maybe you want to have books in the library that contain sensitive information, but you've just sort of black-lined out those kind of sensitive bits of information. We've created a tool which we call our boundarizer, which is sounds like a contradiction in terms, is a small large language model that can be completely deployed on premises, which actually censors sensitive documents. So it just takes out anything locally, which might be considered personally identifiable information, or which might be considered secure. And then you upload that censored version, the boundarized version, into the cloud and use that instead. So there's all sorts of ways that you can meet any levels of security requirements with this tech.
So the idea that AI is in too early stages or is too broad or not applicable to defense is totally wrong.
Do you know, if you had said in 1993, all of your computers are going to be connected up to this thing that's also connected up to all of Russia's computers and is also connected up to all of China's computers, I'm guessing that most people working in IT security would have told you that that was never going to happen. But of course it did.
Yeah.
And it happened because the advantages massively outweighed the disadvantages.
Yeah. Rob, can I ask you, you work in AI in defense for a while. What's the state right now in defense what's the uptake of AI? What does it look like? What are people saying? What are the conversations?
So I think there's lots of different kinds of AI, and obviously a large language model is one of those kinds of AI. You've also got things like autonomous systems. You've got things like computer vision. Sorry. So there's lots of different kinds of AI. Obviously, large language models are one of those, but there's also things like computer vision. There's things like autonomous systems. And if you look at defense from a warfighting perspective, it goes through different evolutions. And they talk about this idea of fifth generation warfighting. And at its core, fifth generation warfighting is about having sensors that sense the environment, about having effectors that do something into the environment, about having decision nodes that make some decisions based on the information that it's receiving on the environment and what it needs to do. And that's all connected by an operational network. So from a warfighting perspective, the advantages of AI across all three of those classes means that you can process the enormous amounts of information much, much faster. And it gives you that advantage over your adversary because you're able to go through what they call the OODA loop, the observe, orient, decide, act loop, much faster than your adversary. And that means that you're much more likely to win. So from a warfighting perspective, AI is definitely front and center. AI across all its variants is definitely front and center. Defense are exploring it kind of more broadly about how they, I mean, if you think robots are a way of automating physical tasks, AI and particularly large language models are a way of automating, I guess, white collar tasks, the boring things that you would do sitting in front of your computer every day. And I think defense are only at the beginning internally of how they come to grips with that, particularly because their systems and their processes are quite, it's a large organization, it's quite bureaucratic, change is difficult. But I know within Army, within Navy, within Air Force, they're all really pushing this idea of large language models for robotic process automation, for understanding what's going on across the defense industry, the defense environment, the defense organization itself. So they're definitely using it, but would I say that they're at the cutting edge of a lot of this stuff? Some people are, but it's not, the future's here, it's not widely spread. I think that is the same in defense. The future's here, it's just not widely spread across the defense organization as a whole.
And I think historically you can see, maybe 50 years ago, some of the innovations or generally in society, innovations might start as something that happens in defense and comes out. But now with like space, the rise of space industry, for example, the privatization of space is an example of something happening in the civilian sector that is now feeding back into defense. And it seems like AI is that. Sean's presentation is showing us that this change is coming. It's not coming from within defense, it's coming externally to defense. And they're learning, I suppose you're saying, how to keep up. They're absorbing it into their model. But
do you know, I think that's actually a really critical point because it's something which I hadn't thought of, but struck me as really interesting. Sort of a colleague at this defense conference said to me, Sean, 30 years ago, if you wanted to work with the coolest tech, you went to work for the US Department of Defense, right? They people who had them, you could afford the supercomputers, or like IBM might have had one, right? But if you wanted to work with the coolest, latest, biggest tech, you went to work for the US Department of Defense. You don't do that. Google's got better tech, right, in large language models. Right? OpenAI have got better tech in large language models, in robotics, in kind of all of these other kind of areas, and that's kind of quite a profound change, and changes then the relationship between defense, big tech, kind of the practitioners in the space.
But there's 2 points here, right? There's using capability, which is what you were saying with the OODA loop and how AI can improve that. But then there's also creating capability, and that's what AutogenAI is in the bid writing space. Creating capability requires an innovative sector, which means defense needs to be able to access the capabilities of these small SMEs who can move quickly. And that's the question maybe for you, Abu. How do you think, what Sean's just put forward in his presentation, how will that change the landscape of the tenders that we're seeing coming out? Who will be bidding for them? the state of defence industry in Australia?
I think it's very good. With regards to your point, with regards to SMEs as well, ideally, when we thought about tender trace and what AI will do for the entire landscape in itself, was it would almost even the playing field. So we have an issue with there's a massive challenge with we're not engaging SMEs enough, right? You know, when you look across the board, it is numbers are played with now and again. It's in that sort of 25% year on year, right? So from our perspective, the way we see Gen AI within the landscape, especially in procurement and SME engagement in defense, is just bringing that level of engagement into some level of playing field. Will it ultimately do that, right? We know that the primes do have large spending, enormous spending capabilities, right, to still stay ahead. But we also know that when you use Gen AI, then you can be very focused on what you go for. You're significantly reducing your cost of engagement in the marketplace. So, from my perspective, that's going to be the real value.
Yeah. Can you see it as well? And Sean, this might be to you. In defence, we see often defence will say, we want new general purpose frigates, and we're going to release our requirements in July. We'll, go to tender. We expect responses to be in the box by March next year for delivery 2-3 years after that. What you were saying is, when you have a team that's previously takes 2 months to go through 20 million documents, they can now get that down to, Autogen can do that in seconds. What does that mean then for the timeline to procurement of defence capability?
Yeah, I think that the ultimate benefit of this is it gets a better deal for the taxpayer because it brings down the costs of competition. And of course, a significant element of the cost of competition are the time elements of the cost of competition. So it allows more money to be going to frontline services because you have reduced the amount of time, reduced the amount of difficulty in terms of course, it's quite right that the people procuring the service have to ask detailed questions about their requirement, and it's of course then suppliers need to answer those detailed requirements. But making that easier for all parties and making that quicker for all parties. Essentially, the AI won't write your narrative for you, but it won't tell your story for you, but it will help you put that story together massively quicker.
Yeah. Do we have any questions from the floor?
Yeah, open question. I understand what you're saying about creating software that avoids confidential personal information. How do you go about finding the data and having a detection system that says, oh crap, I've just accessed a 3rd degree top secret clearance document from defence? Do the red alarms go off or something? And how do you stop that happening in the first place with your AI so that you can allow confidentiality to sit where it should and ignore the fact that maybe defence just isn't taking the right procedural controls over their own top secret data, and now we've got a problem?
So in the particular case, the tool I was talking about, the local censorship tool. So that's a large language model. So it's a neural net. It's a function. You put inputs in and it gives you outputs out. The input you put in is your confidential document, and the output you get out is the document with all the confidential information removed. And that's just using the power of these large language models to understand what's confidential, what isn't confidential, remove what isn't confidential. And as I say, then there's no state stored in that. You've got the information which went in, you've got the transformation which is made, and you've got the information that comes out. You take the information that is out, you can do what you like with it. There's nothing stored in the input. And then you've still got your input data, which is in whichever secure environment you were storing your input data in it anyway.
From a security perspective, there's also other controls that would be in place to stop that happening as well. So the standard defence industry security program, you wouldn't have that high level of security of document just sitting easily accessible in your, public Teams folder, for example. There's so many controls around the management of secure documents like that it would be very unlikely that kind of document would be there in the first place for a large language model to ingest.
And it's always existed that, with regards to data classification technology out there. So you've got technology reading metadata to understand the type of document it says and then doing the redaction it needs. So that technology does exist, then exists in the world like this, then, you know, I guess that solves that problem.
Do we have any other questions from the floor? No?
I had one. When you're generally researching, are you in a position where Autogen, for example, enables you to search documents that have been digitized in the Russian language?
Yes. So it's one of the remarkable properties of large language models is that they encode meaning. And then when you find meaning, you're able to find meaning encoded in any different languages and then return it again then in languages of pretty much anything you've got sufficient training for data for on the internet.
So a bidding company who wants to win business in Moscow just says, woohoo, now I don't need to employ a translator.
Yeah, I mean, so it's still not as good as a native speaker, and you always want to have humans in the loop. Well, in fact, it would be against our terms and conditions, but also you wouldn't win. If you took a tender and said, translate it into Russian, and then didn't have any human check after that, I would say that was problematic and would be irresponsible, and that would be breaking our terms and conditions. However, giving the native Russian speaker the documents once it had been translated by our software to run through, check 100% for accuracy, make any kind of minor amendments to, that will make that human 10 times faster.
Actually, that comes to a point you made earlier, is that, you know, what matters isn't writing a good bid. What matters is writing a winning bid. So with AutogenAI, can you go into a little bit more detail about what the role of the human is? At what point does the human get involved? What parameters is the human setting?
Yeah, so human in the loop, as it's known in AI, is extremely important to us the entire way through the process. So, and that's right from, okay, I want to answer a question. How will you ensure that contractors on this project are suitably security vetted? Like that would be a question you might ask. So we would start from what we call our ideation. So we try and use the AI to mimic how humans would do this if they were doing it without AI. So we'd start by ideation. So I'm going to go and read everything we've ever written previously about how we've done security checks in the past. Then I'm going to go online and I'm going to read everything the internet has to say about best practice in doing security checks. And thirdly, I'm also just going to make some stuff up using this remarkable power of AI. And I'm just going to come up with, right, here are 20 ideas, some of which are from your library of previously written material, some of which are from best practice documents, which we've sourced from public sources, and some of which we've just made up. Now, you as the human are going to review those sources, review those ideas and say, actually, here are the ones I want to include in my response. Right swipe, here are the ones I don't want to include in my response because I don't trust the source of the public source, or I don't trust the proprietary source, or it's just been made up and I don't want to put that in. I've checked it and I don't want to have that. So now, okay, great. I've got these 8 ideas, which are going to form the basis of my 3,000 word response. Again, human is now going to say, this is the narrative structure I want. Why? Because humans are better than AI at narrative structure. But we make it super easy with the UI that you can just move it around, right? Okay, fantastic. Now I'm going to ask the AI to write me my first 3,000 words on that. Fantastic, the AI's written it. Again, I've got the sources, so I know exactly where those sources have come from, which have come from previously. Now I'm going to go through that and iteratively improve it. So I've read the first paragraph and I go, that's great, but you know what? We need to really include a bit of evidence, a case study. Great, fantastic. Highlight it, add a case study. Now read everything that I've written, find the most relevant case study, add it, and incorporate it into the answer. Oh, this customer is particularly interested in environmental sustainability. Rewrite the answer, but add in kind of the win theme of environmental sustainability. Make sure we're including that in the answer. So you can iteratively improve then on the answer to get it better. And then we've got our review feature. So you can actually put in the criteria for scoring the question, put the answer that you've written, and then you can use AI and those scoring criteria to tell you to do your first pass review to say, oh, hey, this paragraph was good, but it would have scored higher if you'd included X, Y, Z, and then you can iteratively put that back in into your answer. So that's like about 1% of the ways that we help people get to winning words. But that would be an example.
In that model, the human is embedded through the process,
all the way through the process,
cradle to cradle. But in defense, I understand, what they're trying to do is reduce these information bottlenecks using AI, where previously you might have one human decision maker sitting at a bottleneck of a lot of information. And Rob, I'm looking at you because this question is to you.
Yep.
How is defense thinking about quality control in AI? How are they making sure that on the operations side of things, AI isn't going to identify the wrong target or give them incorrect information that they then have to make a decision on?
So I'll answer that in the context of warfighting rather than in the context of processing bids, perhaps. Or maybe I can do both.
You do the war fighting.
So from a warfighting perspective, it's really important to keep that human in the loop. So as a military, the ADF is obliged to follow the laws of armed conflict, not just international laws of armed conflict, but also when we go to war, the community sets some expectations about how we execute that war. And so those expectations need to flow through in everything that everybody does. So when we went to Afghanistan, for example, every time there was a target that was prosecuted, they run through a target cycle. There's a whole series of steps. There's a whole series of checks that they need to go through for every single target that they prosecuted, including things like legal review, including making sure that you're getting information from multiple sources. So you can't just say, Fred down the street told me that this guy's, going to blow up your base, and so you go and take him out. But it turns out that they had a personal dispute from years ago, and he's just used you to solve that dispute. You want to be correlating those kind of things with multiple sources. So that is always going to be really important. So the idea of where's your source for that bit of information is going to be really important. I don't know that defense necessarily has come to grips with understanding AI models. So understanding the nuances of it, like where's your training data? Are there training biases in the training data? What's your false positive rate? What's your false negative rate? How do you do the assurance that if it says the answer's X, that it is going to be X all of the time? So I don't think they've got to grips with that yet, but they're working through that process of firstly understanding the technology, but then understanding what tools need to be put in place to make sure that when you decide to take a given action, that you're doing it with information and decision models that are as good as they can be. So it's still emerging. And I think that's one of the reasons why, if you look at where particularly the ADF is in terms of the adoption of some of these systems, it looks like they're behind folk like, say Russia. But part of that is because actually we want to make sure that we're doing it properly, and we want to make sure that these systems deliver the outcomes that they're supposed to.
The question to the panel then, what's the regulatory environment like? For example, Sean, in the creation of AutogenAI, in the journey so far, what regulatory hurdles have you come across, and how have you tried to communicate necessary regulatory changes to defence or to government, either overseas or in Australia?
Yeah, look, I should say this very nascent field. So ask the question, when was radioactivity first regulated? It's discovered, radioactivity is discovered, right, in the late 19th century. When is it first regulated anywhere in the world? So you have, by the way, you've got children with tumours where you've got people strapping radioactive rocks to those tumours because they think they'll heal them, right? You've got all this stuff which is being done with radiation. So late 19th century, right, 1890s kind of discovered. So if no one wants to take a guess, the answer is 1947, after 2 nuclear bombs had been dropped, right? And suddenly people thought maybe we should regulate this stuff, right? Maybe this is something where we should be putting regulation. Now, I don't think it will take 50 years for AI to be regulated, and I don't think it should take 50 years for AI to be regulated. Things move quicker, and this is faster in the public consciousness. But regulation is, and I really don't envy regulators. You over-regulate, and you stop the cure for cancer being found because you've decided you're not going to let AI kind of run, and you're not going to let people innovate. You under-regulate, and you have very bad actors doing very bad things, or you accidentally lead to kind of bad outcomes. So regulation is a fiendish Goldilocks problem. Not too hot, not too cold. It's got to be just right. And I think the answer to that is very heavily dialogue and informed dialogue by all of the players. And I'm always struck when I talk to politicians around regulation. One, and I'm struck by two things actually. One is how much I think people genuinely care. Right? I think politicians can often get a bad name, sort of not always unfairly, but that people really do want to be doing the right thing and getting the right balance right here. And two, how difficult it is for anyone to know what's happening in AI at the moment across the piece, because it's all moving so fast in so many different areas. I mean, we just look at generative AI, but as already been said, it comes just this huge gamut of kind of technological innovation, and how politicians are naturally generalists, and how hard that is for generalists to understand it, to be informed about it. So as many voices, informed voices in the room as you can get to try and get to the right possible answer on regulation, but it's a fiendishly difficult problem.
But you work in Parliament House. Are those conversations something you've been a part of?
Actually, I had a recent conversation with a New South Wales parliamentarian around AI and the regulation of AI, and you hit the nail on the head. I guess we have to innovate, and we need the runway to innovate, and that needs to happen with Gen AI. And Gen AI is in its infancy, so to speak. Would you say, Embryo? Yeah. Right. So it's in its infancy, and so let's see how far we can get with that innovation. I mean, you wake up any day of the week, and there is this net new Gen AI technology that solves things like, whatever it is, but it does solving real human problems. So what this MP was saying to me was that post, a few decisions made by the government, was that there might need to be a stricter regulation in Australia around AI. And my position is absolutely not yet. I think it's too early. Let us get to a position where, let's not wait for bad actors, right? But let's get to a position where we truly understand the magnitude, and we've really engaged the technology in itself.
So, in a military context, there's a software assurance standard called DO 178. And what that does is it looks at different kinds of software. It looks at the way the software is being used. So it divides it up into 4 different classes. And the lowest class is very low consequence software, and it applies a very limited degree of assurance for that kind of software. And for the highest class, it applies, so say for the software that runs your passenger aircraft, for example, it applies a very, very high standard of assurance. And a lot of that software, because it's historically been predictive, as in predictable, so it's all hard coded, and you know that if you put in a 0 at the beginning, that you'll get a 0 out at the end. It's tested exhaustively. So for every single input combination, they understand what the output combination is. And with AI and with machine learning, that's not possible. So if you put a 0 in, you may get a 0, you may get a 1, you may get some string of numbers. And even if you did it 100 times, the 101st time might be different. So that approach of saying, what's the consequence? So in the case of, using large language model for writing a tender, the consequence of an AI giving you a wrong answer might be relatively low. So the amount of regulation that you apply for that may actually be none. Whereas if you're using a machine learning tool to decide how to fly a Boeing aircraft, you want it to be as high as it can possibly be.
Let's not get into Boeing. We have a hard stop, ladies and gentlemen, so we'll end with a boo.
I really want to talk to that point in regards to, high assurance or high risk. How do you then see vendors leveraging the product with regards to the risk to their business? So, for example, right, if we use AI, are we going to technically, it's a low risk or is it high risk? What's that response?
Yeah, look, I mean, I completely agree. What's the worst thing that happened? You get the second best supplier rather than the best supplier. That doesn't feel the same thing as blowing up a village because you considered it a military target, right? There are obviously different ways you want to put that. And again, I mean, because I think the most important, I think it's exactly right. The really important point there is the stochastic nature of these models, the randomness that is built into them, the unpredictability, what's coming out, the black box nature of what's happening inside them, so that it is just unknowable how they're coming to these answers. All of that create, they're enormously powerful, but there are these new challenges, and new challenges are always particularly difficult for humans and politicians and regulators, because we haven't got a lot of experience to work on from the past, where we've already learned from all the mistakes we've made. We don't need to make them again. It's brand new, so you have to imagine the things that can go wrong, right? And that's tough.
Ladies and gentlemen, could you join me in thanking the panel for their time? Thanks, mate. Thanks, Sean.